Hello and welcome to your second segment of Bio News. Today you will be hearing from your three reporters, Karen Gonzalez, Melissa Guzman, and myself, Daniel Sanchez. In primary active transport, the energy is derived directly from the breakdown of ATP. Alright? So, for example, let's say we have a cell, and on the outside of the cell, there's a higher concentration of potassium. On the inside of the cell, there's a higher concentration of sodium. Although on the outside is a higher concentration of potassium, there's still some sodium molecules. And on the inside, even though it's a higher concentration of sodium, there's still some potassium molecules. If we want to produce more energy, what we do is we take the few potassium molecules that are on the inside of the cell and we bind them to ATP to change the shape of what we call the membrane pump. And when the ATP binds to those potassium molecules, it can push the potassium through the cell membrane onto the other side because it changes the shape of the pump in order to fit specifically the potassium molecules onto the outside. Now, when that happens, it opens up space for sodium molecules that are on the outside to travel on the inside to create more energy. Now, in secondary, the energy is derived secondarily from the energy that has been stored in the form of ionic concentration differences between the two sides of the membrane. Now, let's say for secondary active transport, we have a cell. On the inside, it's primarily glucose. On the outside, is primarily sodium. Now, in order to push the sodium, in order to push few glucose molecules that are on the outside through the gradient, instead of using ATP, what happens is we use the buildup of energy from that's been stored to take the glucose and force it through the pump by pushing not only glucose but the sodium molecule through. And even though that allows us to push the glucose through, we also have that unwanted sodium on the inside because it's primarily needed on the outside. And this is where the relation ties in, because even though we get that unwanted sodium, we use the pump on the other side to push it back through, I should say, using primary active transport. That's all from me, folks. Now to you, Karen Gonzalez.
Hello and welcome back to BioNews. I am Karen Gonzalez and today we'll be discussing the different types of passive transport. Passive transport is known as the diffusion of a substance across a biological membrane when no energy is required by the cell to make it happen. There's three different types of passive transport. There is diffusion, osmosis, and facilitated diffusion. First, we have diffusion. Diffusion is known as the tendency for molecules to spread out evenly into the available space. Here, we will demonstrate how diffusion happens as we pour the food dye into the water. The food dye are the molecules spreading throughout the available space, and as they spread out, everything becomes the same color as the molecule will spread into the available space in diffusion. Then we have osmosis, which is the diffusion of free water across a selective permeable membrane. The water diffuses across a membrane from a region of lower solute concentration to a region of higher solute concentration until the solute concentration is equal on both sides. Here, as we can see, we have two potatoes, one which is a raw potato right here, and this is a baked potato. In the raw potato, we see how the salt that was put in the center is becoming to dissolve because of osmosis, the water's leaving the potato into the salt to have an equal balance of water in the outside where the salt is and then the inside of the potato. Here we have a cooked potato where we see that the salt is still the same since the membrane is no longer active and has no water to give to the salt. Our final form of passive transport is known as facilitated diffusion. Facilitated diffusion is when the transport proteins speed up the passive movement of molecules across the plasma membrane. Channel proteins found in facilitated diffusion provide couriers that allow a specific molecule or ion to cross the membrane. This is all we have for the different types of passive transport for today's BioNews. Next, we will have Melissa talk about our next topic for the day. Thank you.
Hello, my name is Melissa Guzman, and today I'm going to be talking to you about osmosis. Osmosis is water molecules diffuse across a cell membrane from an area of a higher concentration to a lower concentration. Today I'm going to be talking to you about 3 different types of osmosis. The first type of osmosis I'm going to be talking to you about is isotonic osmosis. And isotonic is an H2O diffuses into and out of the cell at the same time, so there is no movement of the water. The second type of osmosis I'm going to be talking to you about is hypertonic. Hypertonic is when H2O enters the cell because the concentration solute molecules outside the cell is higher than the concentration inside the cytosol. The last type of osmosis I'm going to be talking to you about is hypertonic osmosis. Hypertonic osmosis is when H2O diffuses into the cell until equilibrium is maintained. So, the 3 main osmosis we just covered are hypotonic, which is being 1, hypertonic being 2, and isotonic being 3. Thank you once again, and my name is Melissa Guzman, and you just learned about osmosis.